We're going to look at end behavior for functions. We have a rational function, y equals x to the fourth plus 3x squared plus 2 over x squared minus 3x plus 1. We want to know, how does this function act when the values of x are very large? We don't really care in this case what's happening when x's are close to 0, but what happens when they are very big? Well, when x's get very, very big, the 2 doesn't matter. Imagine having the number 3 billion and throwing on plus 2. It doesn't really affect the function hardly at all. The plus 1 won't affect it either. And as a matter of fact, the 3x squareds, the 3x squared and the 3x, as long as the values are getting extremely large, they're not really going to affect the value of the function hardly at all. So what it boils down to for the end of the function is we just have to look at y equals x to the fourth over x squared. So if I'm going to describe the end behavior for this one, it looks a lot like just y equals x squared, and the end behavior is shooting off to infinity as x's get very large. Now if we look at the second example, we can eliminate a lot of the ending terms. We can eliminate the 2 and the 3x squared and the 2 for very large values of x, or when the function ends. So this one looks like x to the fourth over negative x. So that means it's going to reduce to negative x to the third. So the ending behavior, we're going to negative infinity as the x values get extremely large. In exercise 39 through 44, though this is taken straight out of the book, find a power function end behavior model for f, and then identify any horizontal asymptotes, which is the same thing as how does this function behave towards the end. Is it going to level out to a value, or is it going to shoot up to infinity or down to negative infinity? So if we have a power function end behavior model for number 43, letter A, it's f of x equals 4x squared. We're not going to count the little guys here. And then this reduces to just 4x squared. So letter A, there's the power function. And for letter B, identify any horizontal asymptotes. There are none, because this function is not going to level out. It is going to shoot off to infinity as the x values get very large. In the second example, we'll eliminate all of the ones that aren't going to matter a whole lot when x gets very large. So letter A, we have f of x equals simply 2. What's left is going to reduce to 2. So the horizontal asymptotes is simply y equals 2. This function will level out for large values of x. In the third example, we cancel out the ones that won't matter for very large values of x, and we end up with f of x equals, now this is letter A, f of x equals 1 over 3x. And when the denominator of a fraction gets very large, that fraction is actually getting very small. So f of x in this case, as x gets very large, is approaching y equals 0. Find a right and left end behavior model for f of x equals x plus e to the negative x. We want to look at this function. We want to know, what does it look like for very big positive x values and very large negative values of x. So if x was extremely large in the positive direction, we'd have f of x equals x plus 1 over e to the x. And 1 over e to the x would get very small because e to the x, the denominator, would get very large. So in this case, the function would act like the function x. So I don't know what it would do. I have not graphed this. I don't know what it would do when x is small, but as x gets very large, it's going to become linear with a slope of 1, just like the function x is. So towards the end, as we go to the right or the positive direction, this function will look a lot like just y equals x. In the negative direction, we would have f of x equals x plus e to the negative x. which would become f of x equals x, well, negative x, I suppose, plus e to the x. Now, imagine the number negative 10,000. Well, we would have, of course, negative 10,000, and then we would have plus e to the 10,000. And e to the 10,000 would definitely dominate this function. It would be much, much larger than just negative 10,000. So this function would look like f of x equals 1 over e to the x for very negative values.